So now we're going to look at what are the outputs, or that's called the range in math. So we're looking at this function, A, which tells us the output for the side length. The side length is the input, and the output is the area of a square. So here, I'm going to put on my x-axis, side length is in centimeters, and my output would be area in square centimeters. So to name three possible input-output squares or input-output pairs, if I inputted 1 for the side length, 1 times 1 would give me an output of 1. And I'm going to pick whole numbers. So if I inputted 2, 2 squared or 2 times 2 is 4. And then I'm also going to say, let's do 5. So 5 squared is 25. So again, our input number is the side length and our output number is the area. Now, all possible inputs are called the domain. All possible outputs on the y-axis are called the range. So earlier, we described all set of input values as any number greater than 0. So I'm going to write that more mathematically precise. I'm going to say the domain would be x is greater than or equal to 0. Now, that's one way to write that. You could also write it in words. Another way that you might see that is we can say you could go from 0 to infinity. And to say you can be equal at 0, you just put this square bracket, but you can't ever reach an infinity. That's why you put the parenthesis. Now, to describe all our possible outputs, that's called the range. Now, if you look, the y values can be any number bigger than 0 as well. So what you would say here is y is greater than or equal to 0. And you would switch to the same notation here. So you could be between 0 and, say, infinity. So now function r is defined by r of n is 40n, where n is the number of campers. Is 20 a possible output in this situation? What about 100? So in looking at this, if you remember, for our campers, we had to be between 5 to 16. So if you look here, if we did 40 times 5, that gave us 200. And if I did 40 times 16 campers, that would give us $640. So is 20 a possible output? Well, if we didn't have that domain restriction before, then yes. And then 100 also would be, sure. But in our problem, they said we had to be between 5 and 16. So our range would be between there, would be the y values between here. So in looking at this, I would say 20 is not a possible output. And neither is 100. In our reasoning, you have to be between $200 and $640. So here are two graphs that relate the camp revenue. Which graph could represent function R and which graph could not represent it? So if I'm looking at this, function R is not continuous. So you can't have like 5.2 people and have a value here. We call that discrete because function R, you can have 5 people, 6 people, 7 people, and there are only dots there. And the reason is you can't have numbers like 5.5 people go to camp, 6.5 people go to camp, and so on. So here, this is function R. And the reason the inputs have to be whole numbers. So this type of graph is actually called a discrete graph. This is continuous. So when you have dots like this at a whole numbers, this is a discrete graph. So describe the set of all possible output values of R. So what you could do then is just list this where you have your input numbers and list it as a set. So you could say y such that, and then you have to get your y numbers between 5 and 16. So one way to do that on a calculator is just remember we put y is equal to 40x, and then we could go to our table and say our numbers can be 200, 240, 280, 320, 360, 400, 440, 480, 520, 560, 600, and we stopped at 15 campers, so that would be the end of our set.